the major thing is that we are turning 2 next month. So next month we'll be celebrating our second birthday. It was kind of 2 years back when we started this in a small room within Microsoft campus. We had more speakers than the attendees. Like I think 5 speakers and 2 attendees in the room, and 2 attendees were kind of a couple. So I think we've come a long way from there. We have like more than 600 members. I think we've even overtaken each other in cloud computing, which was the only cloud computing group existing when we kind of started. And I think we are going neck to neck with some of the bigger groups, like the all.NET. And so I think the growth has been really great. In terms of the attendance, we are still kind of working on it. We are trying to see how can we grow, while our bigger events have seen 80 people showing up. Our smaller events have been a challenge. One of it is to do with the cloud market in Charlotte in general. While I was telling them that my company, Cognizant, we are around like 225,000 employees worldwide. But I personally don't have a project in Charlotte. I just travel all the time. So finding a cloud project or a cloud engagement within Charlotte, it might be in some pockets, but there is not any major. At least in my perspective, not. We are just getting started. We are seeing a couple of customers asking for it now, but I think it's still at the starting phase, not really undertaking or big undertakings like what you might have in other cities. Predominantly banks are, I think, a little skeptical, careful moving into the cloud. That might be the reason, but I think we have that as a challenge. Growing a cloud group in Charlotte is not an easy task. And we are again like focused on Azure platform, which makes it a real narrow segment in the entire industry. So with that, next month we are going to have like 4 different talks, 4 lightning talks on different topics. We are going to cover the API management. We are looking at the OMS. We are looking at the containerization in Azure, and also the DevTest lab. Like 4 different topics. So it's not going to be a 1-hour session, but kind of a lightning talk for 15 minutes. And then we will have some cake cutting also as part of the second anniversary. And
somebody put their face into the cake, like. You're gonna do
not yet. It's after the event. But yeah, so to make a point, I think just show up next month as well. I'm sure it's going to be fun. Something different. Interestingly, our very first session when we started was a very similar format. We had done a 15-minute lightning talk on infra, on the platform as a service, on the data platforms and the IoT. That was kind of like our first talk, the very first talk. That's when we had 4 or 5 speakers in a room and only 2 attendees. That explains that. So, just a quick touch up on what's new in Azure, which we kind of felt among 4 of us that it would be something important and valuable to the group. Let's quickly go over just 3 slides. And of course, like if you want, we can do a session just every month on what's new in Azure for 1 hour. There are so many updates out there. You can just cover all the updates only for an hour. What you see out there. So one of the things which Microsoft launched within last month was the N series. The Azure N series. There is the DS series. There has been A series of virtual machines. The recent introduction was the N series. N series are targeted no more at the GPU capability, the higher workloads which require specific CPUs. So Microsoft is collaborating with NVIDIA and creating this bringing on this cutting-edge GPUs, and they have got 2 flavors. One is the NC series, which is kind of focused more on the compute side of things, more around the tools which kind of require to run simulations and things like that. And then you've got NV series, which is more on visualization, running like platforms like Maya and a lot of other ones. So that's where the focus is on the N series there. You've got the Azure SQL database. They've introduced a new performance tier, P15. Last, the one earlier one was P11, and P15 is kind of like almost 2 times double the power. We can go all the way up to 1 terabyte of storage with your SQL database. So starting all the way from 10, 15, kind of thing, all the way to 1 terabyte SQL database, which I think should cover many enterprise scenarios too. And in terms of the transactional volume, it can go up to 1750 DTUs. DTUs is kind of your performance unit for your SQL database.
1 terabyte storage.
One database, yeah. One database. So that's a new addition there. Then we have got the Azure Active Directory B2C. The Azure AD was initially launched. It was launched as an enterprise identity store. It was not really meant for. It was more of a user repository, but for the enterprise and the enterprise users and allowing the internal applications to kind of authenticate and authorize themselves against the Azure AD tenants in the cloud. What Microsoft has done is that they've kind of gone beyond the enterprise use case, more of a B2C kind of consumer use case. But catering, if your apps are catering to a larger customer base beyond your enterprise, how can you create a B2C and bring in users outside of your enterprise? It supports social accounts like Facebook, Google, and other accounts. There is support for Open ID Connect to all through in terms of the programming APIs. It provides a very uniform access point, the way you have the traditional B2B AD. Now you have this B2C.
So next time we're building a website for users to authenticate and end users, check the Active Directory B2C.
We're using it for our system now. I didn't realize it had gone GA 2 weeks ago. That's really good news. Yeah.
Very quickly. In just maybe a couple of hours, you have a full user authentication and takes interesting stuff.
Yeah, and again, it's based on Open ID Connect and all of those standard protocols, which makes it any application can kind of come and access within the enterprise. It might be downstream app just taking the orders and processing, whatever it might be. You have got the Azure Security Center. I'm not sure how many of you have played around with it, but Azure has got the Security Center right within the portal, which helps you with again applying policies. Now, policies might be with like your system updates. It might be your looking for your OS vulnerabilities or endpoint protection or disk encryption. The network security groups have been applied or not. So you can set up a bunch of policies, and then you can kind of detect anomalies, any non-compliance thing, and alerts being popped, alerts popping out of the system. What they've also done is that they built add-on to the OMS. OMS is still your Azure hub, right, for your operations and management suite. So Security Center would be kind of a add-on or a plug-in into the OMS. So you can go into the Azure Security Center either independently from your Azure portal, or if you are just an operations person, and if you're using OMS, you can just get the same view, same dashboard in the OMS as well, which is very interesting. Then you have got the ASC. Anybody using ASC, the App Service Environment? Okay, so we kind of contemplated using it. We decided not to use it. Too expensive and too rigid. Good to see that they're making at least investments in it in terms of simplifying it. The ASC, the the app service environment, which is kind of like really good. It's a good model because it brings the infra and the PaaS together, kind of a hybrid model. There are some challenges, limitations around like ASC works with Resource Manager, the V2, but the network, the virtual network in which you deploy the ASC had to be on V1. If you're looking for kind of an automation template to deploy your entire ASC, you would have a separate script for your virtual network and a separate ARM template for your app service environment. But now everything is there as part of your ARM templates. You can not only provision the ASC workloads, but also the virtual networks can be part of it. Similarly, the internal load balancer, which was not there earlier, so you only had a public endpoint, a public load balanced endpoint available within the ASC. So now you have an internal ILP for the app service environment, so that helps if you're building an app which is only accessed internally, you do an express route connection, or you have your backend being accessed by your front end, and then you want ILP there. So that's some good additions there. You're using ASC. Last slide. Then we have got the logic apps. So you know that when Microsoft released the app service, I think everything was available for production, but they were just holding back, or they were kind of advising customers not to use logic apps. So web apps were fine, the API apps were fine, mobile apps were fine. Logic apps, they were still kind of churning. They were still formulating the strategy that what would be a good way where logic apps would kind of fit. Finally, we have on GA with logic apps. It's your integration platform as a service. They have got a new pricing model, it's more of action-based pricing model. They've got like some really good set of connectors, which were not really there in the desktop world traditionally. But desktop was not really meant like for the SaaS connectors like Office 365 or Salesforce or CRMs and things like that. So that's supported kind of out of the box. There's a good plan that where you can leverage your desktop on-premise for all your on-premise integrations, and then you can reach out to the logic apps or any Azure integrations or any outbound integrations. They're working on some sort of a strategy as to the bootcamp might help. How desktop and logic apps come together. And then finally, the Power BI embedded. Power BI, I think has been around. Great offering from Microsoft. I was always wondering that how do I get Power BI embedded into my applications, right? If I have a web app or if I have a desktop app or mobile app, how do I get Power BI kind of embedded into my applications? And this is the answer. Power BI embedded. It's more of a service within the Azure portal, like the other Azure services. Available on a pay-as-you-go model. They are making some changes on the pricing. But you can define different access levels based on the report level access, or the entire access control service kind of a model is available for your Power BI. So they've got some tools which you can download to create those reports, upload them, and work with them, so, which I think is a pretty good addition.
Power BI available in
With your Office 365 account, right? You have to.
You have to have
You can pay for more users for the outside of that as well, but you're.
I think that was the case earlier, but I think with this
one
might be worth looking at. I'm not really like played with it. It's more of a recent announcement, but I saw a demo where they were kind of like configuring this within the Azure portal.
Not the embedded one, but the like normal.
Normal it was Office 365. And finally, so today's session we have Keith here, Keith Wood. And as you know, the talk is going to be on the microservices and the Azure Service Fabric. Pretty interesting topic. We have tried covering it a couple of times earlier, but not really in entirety. So it might be a good opportunity for us to hear from Keith and More so, Keith is not only a national lead for Cardinal for cloud applications, but he also leads the main organizer for the Triangle Azure user group, which is the Azure user group in Raleigh. We definitely look forward to collaborating with them a lot more in future, maybe to join events, travel to Raleigh and do sessions there.
Yeah.
Maybe our team is going to go there and do it. And thanks for coming. And,
Thanks.
Looking forward to a great session.
Yeah.
Thank you.
All right. All right, let's see if we can get this thing to work before I get started. And
So Keith, you came all the way here from Raleigh.
I did.
Oh, wow.
Yeah. Make sure everybody's doing what they say they're doing. All right, I'm going to share screen 2. Let's see how that works. Is it there? All right, great. Good stuff. Well, thanks for having me. So like you said, I'm Keith Wood. I help to lead Cardinal's cloud practice from the application development standpoint. So most of my job is related to helping us to win more cloud projects and then lead our largest cloud efforts around that are custom application development. So most of you guys know about Cardinal already, so I'm not going to go into a whole lot of detail. I will tell you that we won the Central Region Partner of the Year award for Azure very recently for building the intelligent cloud. And you know about things that our number of consultants, etc. The focus areas that we have around the cloud are split into these different categories. We have applications, infrastructure, data, and then services such as Office 365. So my focus is in that very first column with the platform as a service, native cloud applications, IoT, software architecture design, mobile, DevOps, especially the STS, and things that you can do with that. We have another practice that focuses on infrastructure, and we've done a lot of really cool projects with infrastructure recently. And we've had some really cool wins for Microsoft where we are moving applications out of Amazon and into the Microsoft cloud. So those are a lot of fun to talk about. From a data standpoint, we have a solution manager Mike here that focuses specifically on big data and analytics, and he's really fun to hear from. So you may want to invite him to one of these sometime as well. And then we do a lot of stuff with Office 365 and identity, etc. So application development. So let's talk about that just for a few minutes. So if you think about application development in a very traditional way, you think of developers being responsible for features. And so what are the other things that other people have traditionally been responsible for? Scalability, availability. Somebody else has probably been mostly involved with keeping up with your infrastructure and watching out for how things scale and your availability numbers and goals, etc. And also around portability of that, you know, a lot of times there's somebody else that's responsible for it. In the cloud world, a lot of that has really kind of shifted to where the people that are building the applications and architecting the applications are more responsible for the full picture of that system. So, so as application development changes, developers are getting a little bit smarter with how they build systems. Now people are building more encapsulated units of business functionality. So you're really starting to pull back and think about what each component is going to be in a system from a business standpoint. Most of the time, you're leveraging these little units of business functionality across a lot of different mediums. So today, you're thinking about your front-end web application. You're thinking about your mobile application. You're thinking about how you're going to deal with all the data that comes from these systems. What are you going to do with that data? And you also, with thinking about applications in this way, you're able to really use whatever tool makes the most sense for whatever the task is that you're working on. So You don't necessarily have to build one big monolithic system all out of one technology these days. You can think about it and split it up in a reasonable way. So who has built microservices before? All right, so microservices is a term that we use to talk about small, independently maintained components that typically are making up a larger system. So if you look at my little chart on the right-hand side, this is an example of the way you might divide up a retail management system into a microservices architecture. You probably would have, if you think about each of the different business functions of your system, you're probably going to think for a system like this about an order service. You might think about an inventory service. You're going to have a list of customers. You're going to have configuration data. You're going to have web content probably, and you're probably going to have a public-facing website or an API. So each of these little pieces that you see here can use whatever technology makes the most sense to deliver the functionality. So you don't necessarily have to think of one great big retail management system anymore. You're thinking of these little pieces of the puzzle. Sure.
So, if you have, you said, at one point that each service will have, or typically have one data.
Yeah.
So order service does notification service. It might have subgroups in it.
Yes.
So those would be a separate microservice.
So
One data.
it just depends on the situation, I suppose, right? But it could, right? You can have some microservices. If you think of, we can keep on going down that track with this slide. So each one of your microservices can have can talk to another microservice if it needs, right? So as you see here, I've got little lines drawn between all the different services, but they so an order might need to talk to an inventory service, right, to find out what is available before an order can be created. An order is probably related to a customer somehow, so those are going to talk to one another. And most likely, customers are going to have bills, so they'll talk to one another. And you may have different types of customers. So maybe you have children of that service that you would create. So there and so as you build each one of these things, you're exposing an API in each one of those cases. And that API, whether it's a REST API or some other form of communication, these services all are able to communicate with one another. And you can choose which of these you would want to expose publicly. You don't have to expose them all. So let's talk about a typical microservice. Each one of these services, as we've said, encapsulates a unit of business functionality, and each one of the services probably maintains its own data to some extent. So you may, and it depends on the way you architect your systems. You may decide that you want a lot of really tiny microservices that each have CRUD operations, and those are the only ones that deal with the data directly. And then you have business services that sit above those that just talk to the CRUD services below, and the CRUD services are maintaining their data, and maybe these business services are doing some sort of a stateful representation of some of that data as well. So there's
Stupid question, like those old data is good.
Okay.
We have this data.
Yeah. All in your data layer, right?
But just nothing doing just calling the data.
Yeah.
Is it similar model like?
Yeah, it's similar. And you can, again, each one of these guys can be architected in whatever way you want. So you could have that architecture built into one of these services if you wanted to, where there was a data layer and a business layer, and but you may just make this whole thing really the data layer, and then somebody else, another microservice that's above, and it's more of your business layer. It just depends on the architecture that you're trying to accomplish, and how many and how granular you want to get with your microservices. And really that kind of comes down to how much business functionality you're trying to build, right? So you may end up building a system where you've got 300 microservices that make up this 50 of those might be the CRUD services that sit at the bottom, and the rest of them are various different business services that you've created to represent various components of business functionality. So, all depends on what you need. So one of the cool things about microservices is that so not only do they each kind of own their own data, but they can also, in a lot of cases, if you have the right platform, they can maintain state across multiple nodes of a cluster without a whole lot of work. And so that maintaining state is something else that kind of helps you with performance, and that's something else that you can accomplish with microservices if you've got the right platform.
Services can maintain their own data internally, so this box.
This little guy right here, yeah. So you may have, so my representation here is that you've got a stateless service, in this example, is just connecting over to a document, to some data store, in this case, DocumentDB. And it's, every time a request comes in, it just goes back to .db and gets what it needs and sends it back.
Doesn't mean that crossover document database of the
Right, you're never going to go from here to here. Never going to do that. If you want to talk, if you need data from the shopping cart from customers, you're going to talk to this, and then you're going to come down here. So then, but in a stateful service model, you may have the service itself may just have its own data store that it maintains on its own without using an outside system to maintain it. If you just need, and there's a lot of reasons why you would do this. There's a lot of reasons why you wouldn't, but you can reliably maintain this data these days without having to worry about it disappearing due to a disaster of some sort, right? So we can talk about how all that stuff works.
Either or thing for the stateful, or
it's either or for whether you're going to do a stateful service or a stateless service, just based off the architecture of the service. But you can do both. Yeah, you could have a back-end data store that you're using, and you just end up taking. So you could persist your data here, but maybe that's not your live data. Maybe this is just where you're saving it. Maybe you're also saving your data here, and this is where you're pulling from on a real-time basis.
You always pull the data from the database, and we maintain a local cache, server cache.
It's exactly the same thing. It's the same thing. It's just you might use a Redis cache for this sort of thing today. This is another pattern that you could take advantage of.
It's another microservice.
Exactly. Right. Right.
There's another microservice that is just taking your cache.
That's right. But in this case, this is all kind of part of the same service, right? So we'll jump into some of that stuff. So as we were just a few more tidbits about microservices. They're independently deployable and scalable, which means that in an enterprise environment, you can do change management on the individual pieces of these things versus the whole shebang, right? They're isolated, making them more testable. Developers are not forced to use the same technology. I've said that like 4 times, but that's one of the really cool things about this is that you might have a .NET API based service over here, and you might have a Node.js based service, and you may have some sort of a Docker container, right? You've got all these different approaches to how you can architect these things based off of what makes the most sense for the task at hand. And then, so of course, one of the biggest things we're going to talk about today is the platform to host these things. So there's several platforms that exist to make this really easy for you, and Service Fabric is one of those. So Service Fabric is Microsoft's platform that we're not in production yet, but we're getting close. We've got multiple projects that are going on right now that are taking advantage. So Service Fabric is Microsoft's platform for these microservice-based systems. So we'll go into each of these different layers and talk about why Service Fabric is such an incredibly cool and flexible platform. So let's talk about the middle layer first. Just talk about what Service Fabric itself is. This is the platform that handles all aspects of It's taken care of your high availability. It's taken care of rolling upgrades. It's taken care of load balancing. It's taken care of just you see all the other things that are out there. It's really it's the stateful services is the other thing I was going to point out. So it's got all these features that are built in that lets you just simply develop business functionality and forget about that platform component. And just this is gonna simplify your life. Communication between services. Yeah, it handles the addressing for you for communication between services, and I'll show you how that stuff works as well. So services are always going to automatically run on at least 2 servers at a time. Whenever you stand up one of these clusters, you're going to have at least 5 servers probably in your main cluster to host these things. And your services that you deploy to this will be on at least 2 of those at any given time. So that helps you with your high availability. Probably more than 2 in most cases, probably at least 3. And then your state is automatically replicated between all of those that your services run on. So if you've got state that is a part of your system, it's just an incredibly useful thing to have this automation to take care of that replication for you. It's as fast as you can possibly imagine. I haven't seen latency in these things yet.
In memory,
yeah, it's in memory, and so it depends. You have to build your servers with the amount of memory that you think you're gonna use for this state. But it's all the idea is that you should be able to. All your state should just be in memory all the time.
Without you worrying about synchronization.
Right, all there. So the platform, just for the service fabric itself, so it's hosted natively in Azure. We can stand this thing up by just pressing a couple of buttons in the Azure portal, and I'll show you how that works. But you can also host this in your own private cloud as well. You can put it in your own data center, or you can put it in Amazon if you want to. You can put it in Rackspace. Whatever you want to do, you can stand this thing up. So the flexibility is there just to give you the portability, so that there's you don't have to worry about your being so tied to one cloud. A lot of big companies worry about building applications that tie them just to one hosting provider. They want to have the flexibility to move their applications elsewhere in case, in case Microsoft were to suddenly go bankrupt, or in case they change their pricing structure 2 years down the road to really screw everybody. So they want to be able to pick things up and move them around. And this gives them that flexibility to stuff they build on this platform. So the microservices themselves, there's several different types of things that you can host in Service Fabric. So you have the stateful, reliable services. That's what we've been talking about the most. That would also includes things that might take advantage of an active pattern. I'm not going to go into an active pattern today because it takes me too long to talk about that. But we could do a whole other session about application architecture using an active pattern. But regular stateful services without that pattern are there as well. Stateless services, those are the traditional services that you're used to writing all the time now anyway. REST-based services, WCF services. Those are, and you don't even, there's other communication. You can really put any communication protocol that you want in front of these services. It doesn't have to be either of those. ASP.NET Core is hosted natively in here now as well. So that's really easy to put an MVC-based application out there using that. Node.js works just fine. Java works. You can stand up containers in there if you want to now. So you can put your Docker containers out there. So that works as well. I haven't actually tried to do that, so don't ask me to do that tonight. But I do know that it works. So Service Fabric itself is heavily utilized at Microsoft, a tried and true platform. Been around for a number of years. This is what they host Cortana on. Azure itself, and many of the Azure services are hosted on this, including plus the platform features are hosted on top of this. .db, Skype for Business, all of those are taking advantage, and several others. I didn't list them all. several others are also hosted on here as well and have been for years. So the platform itself is stable and reliable. So let's build a service fabric cluster. We'll take a look at how that goes.
Nobody uses because services for sure might be running for 10 years.
Yeah. Some they've been running for
Long for microservices.
yeah, they've been doing it for a long time, and I don't know exactly what year they actually started doing it, but I think it was in that 2008, 2009 time frame is what was my understanding.
20 years back, they had this concept.
And they and
Cloud is not innovation. No mainframes were there.
and they just let me see if I can hide this.
People were using services some time ago, but until the idea matured enough to build some communication protocol part of it, how to use that.
All right, so let me see if I can switch this to duplicate, and then I can make sure I'm sharing the right screen.
Go one framework.
This is like the basic job.
Yeah. Anyway, so then you get your reliability tier here. So you can lower this down if you want to, your reliability tier, and it lets you then go as low as 3 servers in your cluster. If you do that, it tells you that it's only supported in a dev environment scenario. So just so I usually just for most everything that I've done, I usually give it at least 5 anyway. And that's all you have to put for this. And the custom endpoints, we'll go over some of that stuff separately. So I'm not going to set any of that right now. And that's all you got to do. So you can just press OK on this. And then the next step is going to ask you to set up your security. So what this is asking for is a public certificate, right, from a public certificate authority. And it's going to use this for secure communications between the nodes. And so you want to make sure that you provide a certificate for this. And the way that you typically are going to do that is you're going to put a certificate in a key vault, and then you're going to just provide the other information that goes with it. So I don't have a certificate in a key vault for this demo right now, so I'm just going to click on unsecure. It'll tell me that I can't change the security configuration after I press OK. Fine, I'm going to tear it down, right? But you want to make sure if you're doing this for a client, you're going to want to make sure you've got that certificate in advance. So just be aware of that. And then that's really all there is to it. So I'm going to press create, and it's going to start creating this. Now, so like any good TV chef would do, I have a pre-built one. What's that? How am I creating it? That exact same way, except for I've got a certificate. So, I understand what you're saying. Yeah, so typically we're going to deploy this using ARM templates with PowerShell. And so that's the most common way, the most common approach that we take with this stuff. And that's going to then be integrated in our release processes that we have. So for our dev environment, the first step is usually we create the environment as we want it to be, and then we grab our ARM template from that environment, and we pull that in and we put it in source control and everything, and we change it to what we need it to be, etc. And then we go and use PowerShell to deploy that out later. So that's the most common approach that we've got.
I just wanted to understand what did we create exactly? Did we create a VM?
Well, that's where I'm headed right now. Exactly. So I've got a pre-built environment here that I'll show you, so we don't have to wait. It takes probably about 30 minutes or so for a Service Fabric environment to be provisioned. So and what that's doing is creating a virtual machine scale set. And then of course all the other stuff that goes with that, right? So a virtual network, storage accounts. And then a load balancer and a public IP. Those are all being created for you through that one thing. So this is what it looks like whenever it's done. So we've got our virtual machine scale set, like I said. There's in this case I did 5 servers, just like I just showed you a second ago, and you see all 5 of those servers are here running. Now, so let's just and then the load balancer, the public IP, the VNet, and then the storage accounts that are associated with all of this. But the thing that's the most interesting is the Service Fabric itself, right? So you got a little line item inside of that resource group that has the Service Fabric cluster. The Service Fabric cluster is going to contain, is really your management environment for Service Fabric. And it's gonna know about all of the nodes that are in all the clusters that you've got related to Service Fabric, and then it's also going to know about all the applications. So you can look at that from here and see the nodes of the server. You can do some access control with it. You can check your node types. You can from here you can see again your nodes, your applications. And I have one deployed here already. And then settings, other security, and then of course your ARM template. So let's go back to the overview, and I'm going to click on.
That's a node.
Yeah, it's a VM. It's a VM.
So in that environment, we created one VM. So what that node was.
Each node is one VM.
Okay.
And so we've got 5 nodes, so 5 VMs. So these are all D1s that I just created here. It's all part of a VM scale set. Oh yeah, they're Windows VMs. Yeah. It's in Azure. So for deploying this in Azure, using this method, it's going to deploy them on Windows VMs. Now you can download the bits and you can install them in Azure or anywhere else on Linux, on a very specific version of Linux. Let's be clear, and then or on Windows Server 2012 R2. You can do the Docker. You should be able to do the Docker. You can install Docker itself on Windows, and then it create, right? Can't you put? Yeah, and then within that. Yeah, but within that, you're going to have your containers, which are all little Linux containers, right? So from my understanding, you can host the Docker containers directly in Service Fabric. So, but it's 2016.
So you would deploy a Docker container on Service Fabric, under Service Fabric would have your.
Right. That's my understanding. I haven't tried it, so don't quote me on too much of that stuff, right? That's just one step deeper than I'm in. Okay. Yeah. Let me just go to the management interface for this for you. So this is how you manage your Service Fabric environment. It gives you your own little UI that gives you a little bit of information. It gives you a nice dashboard to look at as you come in. Sure. Yeah.
Like let's say I'm a developer, right? You're working 8 hours a day.
Mm-hmm.
So how does the continuous deployment or continuous delivery model look like when I check in my code every time? Either I want to see the Corona cluster or the best team of mine.
Yeah.
So how do you distribute?
We don't include the creation of the Service Fabric environment in the release process for the application. We have our own release that we process that initially does the Service Fabric environment creation. And then, so the deployments, the continuous integration, the continuous deployments are all pushed into the same Service Fabric environment and for dev, for example, right? So every night you're going to push, your build is going to push to Service Fabric. And if you have 30 applications that are a part of your system, right, you might have 30 separate solutions that you're developing for one application just because you want some separation between teams or something like that. Then all of those can deploy to the same Service Fabric environment. So you keep it separate. So it's not going to try to redeploy this.
So you provision the cluster separately, and then
the apps.
Release pipeline, like, or your deployment pipeline is separate.
Exactly. That's right.
You kind of deprovision that every night, or kind of stop instances, or the cost? Because most of the developers, right, they might just work 8 hours a day or 10 hours a day.
Yeah. We typically are not deprovisioning them at night. Now, it's not that you can't do that, but I don't, just because.
Is there a stop kind of thing?
It's a pain to stop it. It's kind of it's not as clean as what you would want. But you can do it. You can write a PowerShell script that can turn it off and then turn it back on again. No. Yeah. 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 I'll show you that. Might as well do that while we're here. So, like I said, I deployed an application here already, so we could look at it while we're in. So this is under this application, or under the application's header. You see each of the applications listed, and each one of those application has a little URL that starts with fabric:/, and then the name of the application. And then each of these are separate apps below that, right? So this is my solution, my Service Fabric project, that you'll see in a few minutes whenever I go into the code. And then these are the actual deployable applications. So that this web application, this is an MVC, a .NET Core application, and you can see that it's deployed to all 5 nodes, right? It's on all 5 nodes of the system right now. And so then I have a stateful service, this up here, and it's deployed to 3 nodes. It's got a primary, which is where all the data is written to, and then it's got 2 secondary nodes, which are active also, but it's just reads that are going on there. So that's how you see what node, and so you can see that it's in, yeah. What's that? Yeah, so this is a stateful service, which means that this is one where it's maintaining the state and it's replicating that state across the nodes. So it's got one node where the state is writable, 2 nodes where that state is readable. So you're writing all your state to that first guy up there, and then it replicates down to the other 2. And if that first guy goes offline for one reason or another, one of the others becomes writable. So. Mm-hmm.
Product catalog.
Mm-hmm.
Whatever it might be, if I just want to scale that, would I have multiple primaries or?
It'll have, well, you can have multiple primaries in different clusters if you want to, but within one cluster, it's going to be 1 primary and a whole bunch of secondaries. You can have, if you need 20 nodes of it, it would be there, but it knows each of those, anything hosted on each of those nodes knows how to write that state back up to that home base without having any kind of, you don't have to do anything special. I don't think, not that I've seen, but that's it's something that the developer doesn't really have to worry about so much. It just kind of works. But I suppose it depends on how often you're writing your state, right? So
mindset now, you move a slider and automatically like 2 becomes 5, 5 becomes 10.
Yeah.
10 becomes 15, but here it kind of looks like that there is primary is always 1. You can increase the number of secondary nodes, but then you will not be able to perform read or perform writes on it or whatever that might be.
Yeah.
So the effective scale.
Mm-hmm. Yeah, the writes, yeah.
Serving capacity is kind of limited.
Well, it's serving everything from all the nodes, right? And so even a write request might happen from one of these secondaries, but it's going to write it back to the primary and then replicate it down. So everything, all of those nodes are active all the time. So you can have 100 active nodes if you need to for it. But it's 50, I think, actually is probably a more reasonable number. But you may have 50 active nodes for this thing, but only one of those is going to be taken, the primary writes, right? Just like in a SQL database, you're going to have one place that's going to be the primary writable location, and it's going to replicate that stuff down.
These are one of the reasons I don't need my you guys have practical experience what we had. I think predominantly around this, right? Because it's kind of a black box, and then we just felt that we don't know too much about it.
Mm-hmm.
We really kind of recommend and take a
Yeah.
with this offering right now. So we kind of build microservices, but we build them on the app service model. We didn't even use ASC. Don't for the costs and all that.
Yeah.
Kind of like multiplied. So that was our thing. Like there might be a more contention on the primary because there are so many secondary nodes writing on single primary now.
Well, but if you're just, another thing to think about is you don't even, the stateful service might not necessarily be something that you want to jump into immediately anyway. You're much more accustomed to writing stateless services because that's the general pattern for anything on the web. And you're going to be, the writable data store is something like .db or table storage or something like that. And you can
count. That's a good example of a shopping cart.
I think the shopping cart is the best example where it's something that, you want to keep that shopping cart, and you might want to keep it for an extended period of time. but you don't necessarily care if it dies per se. Now, even if it did die, you have it. Well, let me go into some of the code and I'll show you what you can do with it. But you can back up your state to storage to make, on a frequent basis to make sure that you don't lose anything.
So how would the application, so for example, it's a shopping cart, the user adds a product to the shopping cart.
Mm-hmm.
So you call some web API method that says add product.
Yeah.
And this would go to any of these servers.
That's right.
Yeah. So how do you know that your primary and, for example, save your state, or how do you save it to the primary?
I'll show you.
Okay.
I got it. I got all that code. So we'll go into it.
I guess the main point is that you can use service fabric if you want a primary and secondary states.
Mm-hmm. Yeah. Or you can use Redis, or you can use, whatever you want to do. It's the same sort of idea where it's just kind of a performance enhancement for you to be able to keep up with this thing in memory in one location without having to go and write it to if it's not, especially if it's data that's not, incredibly mission critical. It's nice to have it in memory. Or if it's data that lives in a data store anyway, and you want to pull it in for performance reasons, it's a good way to do it. Yeah. All right. So this is just, this is a little bit about that service fabric infrastructure. Let me go back to my PowerPoint just for a few more minutes, and we'll go back. Then we'll go to some code. All right, so as I mentioned, you can install Service Fabric outside of Azure. It's in preview for Windows 2012 and Ubuntu, Linux, and you can download that from Microsoft's website. So let's talk about developing software for Service Fabric. So I'm going to show you how to do this in a relatively streamlined way, so I don't take too terribly much of your time. But these are the types of things that you can put into Service Fabric by default here. You can create your reliable actors, as we were talking about, using the actor pattern. You can do stateful reliable services. You can do stateless reliable services, stateless web APIs, and you can do ASP.NET Core, which can be MVC or web API. You can do, and then you can have any guest executable that you want to put in. Right? If you can specify some exe that Service Fabric can execute, it can spin up that process and it can take requests. So, yeah, it's pretty much the stateless. I think I shouldn't have put the word reliable. It's a stateless service that doesn't necessarily have that web API front end. So you can have a service that just communicates through TCP or through UDP. I mean, through in there. So you can make calls to it just using the Service Fabric name if you've got an interface, and not use the REST API on top of it. So I think some people feel like you get a little better performance out of something that's not using, where you don't have to serialize and deserialize the things that are in REST. So the stateful services are never front-ended by REST. Those services are always going to be, you're always going to call those services using more of just back-end Service Fabric API type stuff to get to it. And then you can of course always put a front door on there that is a web API. But it would be that's a separated microservice in itself, right? So let's dig into.
The actor service, like, how does it kind of relate to this? Just a small summary, or
yeah, an actor. So an actor is really kind of a stateful service, and so you would, if you think of actors. So you're going to maintain instances of these actors, really, is what it is, and those become something that is written to your state. So therefore they're using this stateful, the stateful, reliable service technology behind the scenes. But something like, I guess one way to think of it, just an example, would be, let's say that you've got 100,000 meters that are all out in the field whose whole job is to read information about the electricity passing through this meter all day long. And those are responsible for calling you back to tell you about activity passing through, right? So readings. Each of those instances can each be an instance of an actor, I suppose, right? So it's so I could do a whole presentation about actors and how you could take advantage of those, and it's just a totally different mindset. It's a software design pattern, and so we can go into that in a different talk if you want, but it's definitely an interesting way to think about software and an interesting way to think about things, and like think about an actor could be really any instance of any model that you could come up with, and you just keep updating that same guy over and over again. So it's a different pattern. So the actor pattern is something that, again, is an industry-wide thing that other platforms give you the ability to do too. So it's something.
Microservices.
Well, you probably have to look for a book that's targeting the actor pattern, and it'll talk about microservices is what would happen, right? So it's it's something that it's just another mindset that takes advantage of that microservice architecture behind the scenes. But it's just a pattern that you can use to design your system. So it's definitely and Microsoft provides some templates for you to get started with it, but you definitely have to. It's something you certainly have to wrap your head around. It's not something that's going to be perfectly natural based off of the patterns that you're used to following with software development.
For customers, they kind of when we look at service fabric, which is kind of like Microsoft, doing this, right?
Mm-hmm.
Microservices. And look at Google and Kubernetes. Huge difference in terms of support, mind share.
Mm-hmm. Yeah.
Where they build stuff, but yeah, it's kind of like maybe it's not really elevating the value proposition. That it's not really maybe a simplified innovation which can be applied seamlessly and massively.
Yeah. It's not something you would talk that much to the business about whenever you're going in, right? This is definitely something that you would end up as an architecture team making decisions on based off of what your business requirements give you. I think I've read that that Uber uses an actor pattern with their services, and that they're with their microservice architecture that they've got, and other big companies like that are taking advantage of it. Right. So, all right, let's jump into this. So I have this pre-built as well. And that'll save us some time, but I'm just going to show you. I'm going to show you how to create. I can do it from this angle. I'm going to show you how to create a service fabric project in Visual Studio. So the prerequisite for this is that you need to have the latest Azure SDK on your machine, and you need to have the latest Service Fabric SDK installed. And both of those were updated in the May-June timeframe, Service Fabric being more of the June timeframe. Several features were released. They went GA with Service Fabric back in March, April, I guess, around the build conference timeframe, I guess. I guess it was the end of April, early May, and then they threw a few more features in a little bit later on. So you find, once you've got that installed, you find the Service Fabric application under Cloud whenever you go to build a new solution. So we'll call this Charlotte. We'll call this Charlotte's Cloud demo also. All right. So whenever you spin one of these up, you get this dialog immediately, and this is going to really this is just going to create your initial Service Fabric service for you, and then you can always add more of these things as you go. So if I were to select a stateful service, it's going to create that for me, and so I'll just say state service test. So it takes just a second to spin up, and
Question for you.
sure.
So these VMs that we created, can we actually log into them or install, for example, something like that?
You can log into them. I wouldn't recommend. It's going to have the Java stuff on there already, so so you won't. There's I don't think I would log into them and separately install anything though. It's
Does
a
Microsoft maintain the OS essentially?
yeah.
The updates, so you
Yeah. So there's you
You
can
have some dependency, like you can install that.
yeah, you need it to be a part of your package, right? If you so if you've got dependencies, you just want to build it into your package that gets deployed, and that's I think is really important to do that. You don't want to put a dependency in where if you need to grow your VMs, that you need to then go and change and put the dependencies to.
So there's a way to deploy dependencies, some script to deploy or to install the one.
Yeah, there's a power. When they spin up, it should spin up the other stuff too. But what you get with this service, I'll show you. Let me show you what's in this guy here. So whenever you create a Service Fabric application, the application that is in here that is the same name as your solution is the Service Fabric app, and within that you have several things. One, you've got a PowerShell script, right? So this PowerShell script is what is going to use to deploy your application. So you've got a little bit of power just based on the fact that it's using that. You've got configuration, right? So you've got parameters that you can use. You can have there's a local development server that is running on my machine right now that will run the Service Fabric application. Based on that, it's going to pick up whenever I run it locally, it's going to pick up this local XML file here for my local parameters, and that's where it's going to put things like my connection string to .db and other things like that. Exactly. Very, very similar to cloud services with the way that works. And so, and you also get this manifest, right? So if you go into the manifest, you can see various things here. The most important thing to look for is the fact that each of your services that you're deploying is listed here, along with just various little bits of information about it. So you can get, just take a look at what we've got in these guys here. And I thought it was in one of these that shows what port this application is going to be running on. I might have just scrolled right past it. But in any case, you can see the port number that is, and I just can't see it right now for some reason. The port number that this is going to be deployed to. It's not in Fabric. Well, for some reason, I'm not seeing it at the moment, but there's a port number that is going to be used for this application whenever it's deployed. Yeah, you can see where some of this stuff is. You can see what this looks like.
Just really a lot. So what's similar to the cloud service?
Yeah.
It's like the transition from the cloud service to the public.
Right. So, so if I want to add another service to this, right click on services and click add, and I can add a new Service Fabric service. So then I can go and add my ASP.core application if I want to. All right. So we're going to just call this one web app. And whenever I add a core application, I get the same old prompts that you would typically get for any core application that you're adding to make a web application. And then you'll see that show up in here. So, and it of course does a little package restore, just like it does for any of these things. Just takes a second. So if I want to run this application right now, I can, and it'll start up in my local development environment. It takes about a minute for it to spin up, so I'm going to do it from the pre-built application since I don't want to keep you guys here all night long. So I'm gonna run it from this guy here. The only thing I've done to this application is I've added a little bit of code to make it actually do something, and I'll show you how it does that stuff. So if I click run over here. Yeah, no web forms. No, you get core is what you can do inside of this if you want to, and that's going to give you the ability to host an MVC-based application out there, pushing you away from like the web forms approach, and so you just get this. So some of the stuff that you get whenever you start to run the Service Fabric application, you get all the diagnostic events, and then it, the last step that it takes after it spins it up in the Service Fabric cluster is it launches a browser that has this out there. And did I just start the wrong application? Well, let me. Oh, I did. I started the wrong app. I started the one that I didn't. I started the wrong app. I started the one I just created. That's not what I wanted to do. I wanted to start this one. So that'll just take us. I did it again.
Yep.
Hold on. Oh, you know what it is? It's on the other screen. The one I wanted to run is over here. I'll just start this one at the same time. The main difference is that inside of this application, I put the actual code to make it do something. So what I'm going to be doing is inside of my stateful service, I've created a way for me. I've created a model, and I've created a way for me to save that model into the state, right? And there's a way I'll show you how I can take servers out of the cluster, and that state is still maintained. So I can show you a little bit of the code while we. Oh yeah, here. That's the wrong. Of course, that's the wrong one. Take this the other one. Be here in a second. While we're waiting for that, I can also show you the Service Fabric cluster running locally. You see localhost 19080. This is the same thing that's running in the cloud, running local here. All right, here it is. Stateful items. So I'm going to add my items into the state. You see how it just lists it out right here as soon as I add it, and I'll add another one. All right, so I've got two guys in there in the state, and if I want to go and take one of the nodes out of the cluster, I'll show you what it looks like. So in my stateful service, here it is. I am using. This is where I'm adding an item to the state. This is all you have to do to add items to the state. You have one line of code here. It's state manager, get or add async, and then you're giving it information about your. You're giving it information about your model, what you're putting in there, and then what collection to put it into. You might have multiple collections of this stuff, and I've got my collection is just my collection right now is all it is. And then it does this transaction, looks to see if there's already an item that contains the same key. either way, if there's not an item with that key, then it goes ahead and adds it. And if I want to get it back, I'm just I'm doing the same sort of thing, getting or adding async, and I'm just calling out to try to get value async, and I just go pull this ID, and then it puts it into the model. And I can get a list the same sort of way. And in this case, I'm doing an enumerable, and I'm just moving through that and adding it to my collection and sending it back. So that's really all there is to this state manager, right? It's really super simple to use, and it's taking care of all of the work for you behind the scenes. So this is referencing the Service Fabric NuGet packages, and using that as it can communicate with the Service Fabric system that's running on the server. Just using, no, it's just an in-memory store. From as far as I know, I'm not sure what the technology itself is actually called, but just an in-memory data store that they've got that probably has a service that's running on the servers that's maintaining that for you. So in order for me to do that, all I did was I created a model that's in an interface for this service. So I have my stateful item model here, and I have an interface that defines what the methods are in my service. And then I'm referencing that in my web application. And then inside of my controller, I'm simply calling out using this creating this client that where I go call to get I'm calling my method that I expose get stateful items. And the way it's getting to this is that it's using the naming service. There's a naming service or a names service that is on Service Fabric. So you can call and ask for what the name of basically what the URL of a service is based off of you're going to give it. So for this, you see, I'm passing the stateful service test as the name of the service that I'm trying to call, and so I have this little method that I created in the common place up here, service URI builder, and we can call out to the naming service and get the Service Fabric URL for that. So it'll be fabric : / and then it's probably good. So for intercommunication, it's just going to use the application name, and then it's going to find based on the name of the service, we're going to go out and get the IP address of the server that I'm supposed to call and the port number, and it's going to use that to go out and get this information from the service. And
the example you gave earlier, the detail, right?
Mm-hmm.
And those many services.
Yeah.
Like for that one detail management, you have one.
So you have choices, but in that case, for that size of an application where I've got like 8 or 10 services or something, sure, I would put all of those services into one solution and one Service Fabric cluster base, or one Service Fabric service, right? And then so all those things would be living under here. And so then you deploy the whole thing. And so one of the neat things that Service Fabric can do is if you try to deploy this application, it only does, as long as you are doing your builds properly, it's only going to version the services that actually changed. And so based off of what has changed, you can deploy the whole shebang, and it's only going to perform the update on the Service Fabric environment of the services that actually changed. So I can have one massive solution that contains a whole bunch of services, and it would really only deploy the ones that have been modified. Now you have other choices too. You could split this thing up into 10 different projects if you want to, or 10 different solutions with different Service Fabric projects in there where you deploy them separately if you want to. You can go to the same Service Fabric cluster, it becomes a different application, but the applications can communicate with one another. So.
Order service.
Say that one more time.
So each service.
Yeah.
Right? That would be one project.
Yes, each service would be a project in here. Yes, and you would deploy it out that way.
And because they are clustered, service you are able to run all the others.
Yeah, and you can, and the methods that I'm calling from that little URI builder, you can do from other things. I just made that because it made a simple way for me to find the URL of the easy way for me to go and get the name of that service from one place. Yeah, that's right. It just knows by name, and then based on that name, it knows the service fabric will tell it where to go to get that. As long as they're all part of the same service fabric system, service fabric cluster, they can talk to one another. Service fabric can tell it how to get there. Well, you're probably gonna, so for Geo, you're probably gonna want to have multiple service fabric clusters, if nothing else, just for disaster recovery purposes, right? Or even geographic purposes. So if you have a global application, you're probably going to put a cluster in North America, and you're probably going to put one in Europe or something like that.
It's not rapidly designed.
You could, right? You're probably going to design your application to run across just a service fabric cluster and be able to just engage within that one.
You can make your service public. Any other service.
Absolutely. So that's yeah. So one of the things that I didn't tell you yet is that all of these services none of them are publicly exposed until you make the decision to publicly expose one on your own. So the load balancer, so if you want any of these to be public, and you'll want at least one to be public, you have to go to the load balancer and expose the port that it is. So you can, so for example, I might want to expose my web application and nothing else, right? I want the rest of these services to be private to just my web application. So the web application itself can call out to all these different services, and I expose the web application on port 80 and 443 on my load balancer. And everything else is locked down behind the scenes, so they can all be secure. You can put more than one out there if you want to. It's your choice. All you have to do is pick a port that you want to be public, and then you can route to any port within Service Fabric, and the load balancer will drive it to any of the servers where that service is hosted.
Do they have some other, like messaging, for example, kinds of baked into Service Fabric or communication?
Yeah.
For example, like storage queues or something like that.
So no, to get to storage queues, it's the typical way that you would get to a storage queue. So if you just the normal .NET approach to calling out to that storage queue.
Like this is the standard way
Yeah.
for services to communicate through REST API.
Either REST API or through this service proxy that I showed you up here. So you got the service proxy that if you just define an interface, you can on your service. You can use that interface, and you could then call methods against your service using that proxy, right? So you've got that approach. That one is in my opinion, that's probably the most performant approach out there. Other people want to expose all their services with REST because they want to use it for testability purposes. They may have a test framework that calls their services using REST, and that's they just want to set that as their standard. So you have various approaches that people take. Yeah. Super easy to get a legacy web API service out here. If you want, and WCF too. If you want to put a WCF service out here, no problem. Well, you could do stateful, or you could. You're probably going to put most of those in a stateless. because if they're legacy, because they're stateless today most of the time. So you just bring them in as they are and use for my I have another example up here real quick just that I can show you. For stateless services, here's a stateless one here. So for stateless services, this is an API. You just have to make sure that there's an ON component that you've got on there for it to host it, right? So there's no IIS on these servers. Everything is going through. Everything that's coming out of there is hosted through an ON type of an approach. So you see how this one looks here. You've got your ON listener that's out here. You've got your program and your startup. These things are required to be in there for it to host one of those other types of applications, but it's really super easy to put it in. All right, so I've said a lot of stuff. I showed you a few things. I didn't show you how to expose the port, but that's the same way as you would on any on any load balancer. If you've used Azure Load Balancer, you know how to expose these things. Any other questions that you guys have?
For example, if you want to integrate your service fabric, if you have your virtual network service,
Mm-hmm.
your virtual network,
Yeah.
You want to connect to your on-prem.
Yep.
Maybe you have some service or web app over there.
Yep.
You want to call your web services or service fabric.
Mm-hmm.
Is this scenario possible?
Yeah, you can use whatever VNet you want. You can use whatever IP range you want. So you don't have to deploy. If you want to use an ARM template, you can take out the VNet from your ARM template and reference another VNet that's out there entirely if you want. It's in a different resource group. So and that VNet can be connected through a VPN or ExpressRoute over to your on-prem network.
So if I have a VNet already,
Yeah.
Yeah,
you just
I can just deploy my service.
Yeah. Yeah, you just stick this thing into your same VNet and it works. And then you're totally connected on-prem, and you can use you can expose things just internally if you want. You can use your you can put the rules out there, whatever you need to do. Yeah. That's the cool thing about Service Fabric is it's really, just a set of VMs that you operate just like any other set of VMs. But it's got just this little bit of platform stuff built on top of it that gives you all this incredible flexibility. And again, they're managing the patches on these servers and everything for you as long as you're using this template. You can do this if you want to install Service Fabric yourself. You can. There's a lot of other scenarios that you can cover probably with installing across various geographical areas too.
And the price point is just the resources that you provided inside.
Yeah, it's the price of the virtual servers and the storage. That's what it is. So
But they have to be standard.
the storage. Oh, the machines. Well, the machines you can use whatever virtual machine size you want. I picked the D1 size, but you can pick any of the D series. You can pick all the way up to G5 if you want. You can pick down into the A series. Do whatever sizing you want on those. Oh, I was going to take one of the nodes out and show you how that worked. Yeah, we can do that real quick. We can go here and let's just see what we've got. This is localhost, Charlotte Cloud test type. I've got my stateful service. This is in nodes 4, 1, and 3. So if I take 4 is our primary right now. So if I take 4 and I tell it to pause, right? So it takes just it's disabled now. So if I go up here, my nodes still says node 4 primary, but I need to refresh that. maybe my pause, maybe it's. Deactivate.
How do you know which one? Okay.
Yeah. So I should. Oh, it stopped then. Oh, the debug. Well, okay. So you see, whenever I did that, the application. So now my primary, you see, is node 3 on there. So it switched
Do you
it.
really care about which one? Like when you develop your application over here, do you really care which one is the primary?
Oh no, you don't care, especially in the debugging phase right here. You really don't. But this is just to demo the fact that you can turn them on and turn them off if you want to. So it's.
You don't even probably decide like which one is the primary.
No, you
It
have.
just does it for you.
It just does it for you, and you'll always be that way. And it'll adjust how many servers it runs on automatically. So you tell it how many servers you want in your over here in your manifest. So I'm gonna so you tell it the target size for your environment 3 and the min 3, but I could give it a higher number here, and it'll scale itself too if it realizes that it needs to scale bigger than 3. It'll scale up to a larger number of nodes if it realizes. The VM, no, so you have to tell it how many VMs you want in your service fabric environment, but you can
You can only scale what you said.
yeah.
It's not like scaling.
Well, then you can have more than, you can have more than the number of servers.
Oh, right. Well, this number of servers are your nodes.
But you can have more.
Oh, right, yeah. But but you can scale up. You can make the environment larger if you want to.
It's essentially a double scale.
Yeah.
Scale the number of instances.
Yeah.
And then you can also scale the underlying infrastructure.
Right.
It's just that second scale is more expensive in terms of like time.
Yeah.
It takes, like you can scale up to a certain amount, and then you scale other lines. After that, you can scale that down. It's just like minimum cost of your 5 minutes.
Exactly. Yeah. So anyway, if I were to go back to my application on the web, you would see that all that state is still there that I had. It just switches things around for you. So my ABC, DEF would still be there, and I could go and do that probably. Is it still running? Probably is still running. No, I stopped it, I guess. But in any case, you would see that sitting out there.
This can be done outside of .NET, this can be done with Java somehow.
Mm-hmm. And
So that was my question is, so you had the inter-service communication. So let's say I have a customer service and I have an order service, right?
Yep.
I come and look up an order, that order service is.
That's right.
So if I'm going to do that the way you did it, I'm going to have to do it in Java. I'm going to have to include some kind of service library dependency or.
So the way I did it here was using that proxy and the interface, but you don't have to do it like that. You can expose the REST if you've got a REST interface exposed, you can just use use what you typically would use in Java to expose that REST interface, or if you're reading from one of these other services that has a REST interface exposed.
How would I, so I'm your order service, and I want to get some data from
Mm-hmm.
How do I know where to go? Right?
Well, you would. So, yeah. I got you. You could still. I think that in Java I think they have a. I think that you can reference. I think you can reference a component that gives you access that naming service too, for you to be able to go out and figure out what node something is on, for it to give you the information about how to call it.
So I would have to pull in.
Only for, yeah, like a jar or something, but only for that naming service piece. Otherwise, everything can be as you typically would do it. If you can expose a REST API or you can call a REST API, it's going to be that's how you're going to interact with it most likely.
So like, what's the IP address?
Well, that's what that naming service would give you, right? The name service is going to tell you what the address is of everything. So that you're going to deploy a Java-based service to this the same way you deploy a .NET service, and that it's going to be deployed out as an executable, and it's going to get a port number that's exposed in Service Fabric, and it's going to be put on those nodes just like these other applications are. And that name service is going to tell you how to get to it. And it's going to, you probably expose a REST API out of there for other services to be able to call. What you would probably do.
It is a surprise when I did not explore these kinds of scenarios of communication.
Yeah, and I think
it would be easier for example, Java or the other technology to all communicate.
Yeah.
Service bus or something like that.
Right. Yeah. There may be. I don't know what they've got built as far as components that you can build into a Java application for Service Fabric. I don't know, but I would assume that there's at least something that lets you get access to the name service. And that's really the most important thing. If you can get access to the name service, you can call anything else in Service Fabric.
Always say big for the stateful service.
Yeah.
Probably for Java. Stateful service the same way by
yeah.
Adding, your state to it. It's just a platform that benefits the state.
Right.
Assuming they have something.
They probably do, and if they don't, they probably will soon. But that's they want it to be an open platform that you can host really anything in. So they may or may not have all the pieces that are necessarily available for you to interface with all the Service Fabric components. I would assume they do for Java, but I haven't tried it. Yeah.
I would be surprised if they did.
Yeah. What other questions do y'all have?
So where do you actually build one classic structure types versus microservices approach?
Well,
there is a divide on, or in how much of a divide would be actually transition from the small set classic to
yeah. So you're right. It's cheaper probably if you don't have a huge application that's going to actually take advantage of this much infrastructure anyway. Sometimes it may be harder to justify the cost of a big infrastructure, like Service Fabric. It's not hard to, you can host the same sorts of applications in either. So it's just a matter of it would probably be it's a really simple transition. I can tell you it is to move a web API that's using an ON based host into a Service Fabric application. It's really super simple. Well, it's
the storage.
Minimum of 5 nodes, which kind of grow. Which if you'd only need one node of a $50 web app service, then it's hard to justify a $500 environment, right? But so it's the divide probably is that you really have to the architect that designs the system has really got to put a lot of thought into all his different options at this point, right? You've got your app services, and you've got your older classic cloud services even, and then you've got Service Fabric, and then you've got a regular VM. So and there's other things, you've got other options for various types of application components in the platform too. So there's always a lot of stuff to think about whenever you're designing a really strong cloud-based platform application. I tend, if it's a larger client where it's a large-scale application that I know is going to need a relatively large infrastructure anyway, I'm probably going to go Service Fabric these days. Yeah, I'm probably going to go Service Fabric for them right now because I think that that's probably their best bet and their the best platform for the long run for somebody like them. If it's something where I'm just building a web application and I don't need a broad set of business services, maybe I'm just going to use the app service.
If your application is complex enough, if it can save you enough on developer complexity, your developers are the most expensive part.
Right.
Right. So if they can save them time, make them more productive.
Yeah. Yeah. I mean, you have to weigh all the costs that go into an application development project, and the infrastructure is one of them, and you just have to scale it based off of how you know that they're going to use the system.
You have a web application, for example, back in Microservice, that's like two different, at least VMs, and each of these will be load balance. Here are 4 VMs that you have anyway.
Yeah.
4 nodes.
Right.
So what's for one application?
Yeah.
Yeah, it might not be too low.
Yeah. I mean, you just got a lot of options to think through. All right. Well, thanks so much for having me today. Glad to do this.
Awesome. Thanks a lot.
Yeah. We can.